In this video, I'll be solving the 8th problem of IOQM 2024. So we were given n be the smallest integer such that sum of digits of n is divisible by 5, as well as sum of n plus digits of n plus 1 is also divisible by 5. So and we have to find the first two digits. So normally, like when we add 1 to the number, the digit sum should go up. But if the number is ending with one or more nines, then these nines roll over to zeros, and which decreases the digit sum. So if we consider in this case, so for example, or like in order to understand this, so for example, if we consider 237, for example, if we consider 237, so 237 plus 1, that is 238. So here the sum of the digits is 2 plus 7 plus 3, 2 plus 3 plus 7, so that is nothing but 12. And here the sum of digits is 2 plus 3 plus 8, that is nothing but 13. So when your number is increased by 1, the sum of digits must also be increased by 1. But what happens when we are having 9 in the end? So when we are having 9 in the end, that will reduce the value. So 239, 240. So this will give us the sum as 14, and this will give us the sum as 6. So, and similarly, if we are having 1299, let's say, so it will become 1300. Here the sum of the digits is 4, and here the sum of the digits is 3 plus 18, which is 21. So in summary, like suppose if there are some k trailing nines, the digit sum changes by, so here, why am I saying about this in this question is, so here in this context, like sum of the digits is divisible by 5 and sum of n plus 1 is also divisible by 5. So suppose like if 9 is not there in the end, so then like if we are adding 1, so sum of digits n is congruent to 0 mod 5, and n plus 1 will also be like some 1 mod 5, like if 9 is not there in the end. So if units digit is, so here the casework is very simple. So if the units digit is 9, then it is possible, because if units digit is not equals to 9, if this not equals to 9, so then n is congruent to, if n is, sum of digits of n is 0 mod 5, sum of digits of n plus 1 won't be 0 mod 5, because it will be 1 mod 5. So with this, like we can conclude, suppose if there are k trailing nines, the digit sum changes by delta is equals to 1 minus 9k. So the sum should be it differs by 1 minus 9k. So that means here, like in this question, like 1 minus 9k, that difference, so n is congruent to 0 mod 5, and n plus 1 is also, sum of digits of n is congruent to 0 mod 5, and sum of digits of n plus 1 is also congruent to 0 mod 5. That means this difference, delta, is also congruent to 0 mod 5. So that means 1 minus 9k is congruent to 0 mod 5. So where this k denotes how many nines are there in the end. So that implies, so 1 is congruent to 9k mod 5. So 9k mod 5 is nothing but 4k mod 5. So that means like 4k is congruent to 1 mod 5. That means k is equals to 4. Because 16 mod 5 is also 1. Or like you can also do modular inverse over there in order to find the exact value of k. But like here, like our k value is 4. That means there are 9 trailing digits, like 9 digits which are 9 trailing nines after a particular digit, after a particular number. So ABC 999, or it can be any digits, but we want the smallest one. So 9 plus 9 plus 9, that sums to 36. So but the sum should be divisible by 9, and it should be the smallest possible digit. So that means we can just keep 4 here in order to make this divisible by 5. So now like if we find the sum of digits is 40 and sum of digits of 5000 is 5, and both are divisible by, sum of digits of 50,000, if we add plus 1 we'll get 50,000, and sum of digits of 50,000 is also 5. So the number that we are asked to find is 49999. So basically the first two digits will be 49. So the answer for this question will be 49. So that's it for this video. We'll meet in the next video.